Today we are going to discuss about rational numbers chapter 8th class. So before we are going to discuss about rational numbers, some numbers also we have discussed. That is natural numbers. Natural numbers. Natural numbers means that is only counting purpose. The natural numbers begins with 1, 2, 3, 4, and so on. Next, whole numbers. Whole numbers. Whole numbers begin with 0, 1, 2, 3, 4, and so on. Next, integers. Integers. Integers are, that is, some positive numbers and negative numbers along with 0 and so on. -3, -2, -1, 0, 1, 2, 3, 4, and so on. Next, rational numbers. Rational numbers. Rational numbers means a number which is in the form of P by Q. A number which is in the form of P by Q. Here, P comma Q belongs to I. I means integers. And Q is not equal to 0. Q is not equal to 0. It is denoted with rational numbers denoted with Q, capital Q. So Q is equals to X such that X belongs to X is equals to P by Q, and P comma Q are integers, and Q is not equals to 0. This is a rational numbers. So example 1, 2, 7, 3 by 2, 1 by 4, 9 by 6, -3 by 2, -8 by 7, 0, and 11 by 2. These all numbers are called rational numbers. These all numbers are called rational numbers. Next, 0 by 5 is equals to how much? 0 by 5 is equals to 0. So 0 by anything, 0 by A is equals to 0. A belongs to Z. A belongs to Z. 0 by anything, 0 by anything, Z or Q. A belongs to Q. So any number is equals to 0. Again, anything by 0, anything by 0 not defined. Anything by 0 not defined. So A by 0 is also not defined. That is infinite. Not defined or infinity. Next, in our chapter, rational numbers, some properties are there. Some properties are there. What are they? Properties. Properties. First one is closure property. Second one is commutative property. Commutative property. Third one is associative property. Fourth one is identity property. Next one is inverse property. These are the properties. These are the properties in our topic. So, first we are going to discuss closure property. Closure property. Under addition. Closure property under addition. Closure property. What is the closure property? First of all, 3, 5 belongs to Q. 3, 5 belongs to Q. Then 3 plus 5 also belongs to Q. 3, 5 belongs to Q. Then 3 plus 5 also belongs to Q. This is a closure property. Another example, -5 and 2 belongs to Q. Then -5 plus 2 is also belongs to Q. -5, 2 belongs to Q. Then -5 plus 2 is belongs to Q. In generalization, A, B belongs to Q. Then A plus B is also belongs to Q. A plus B is also belongs to Q. This is a closure property. This is a closure property under addition. Next, under subtraction. Closure property under subtraction. Closure property under subtraction. So, here also same 5, 9 belongs to Q. Then 5 minus 9 also belongs to Q. 5, 9 belongs to Q. Then 5 minus 9 is also belongs to Q. Another example, 6, 8 belongs to Q. Then 6 minus 8 also belongs to Q. 6 minus 8 also belongs to Q. Next, multiplication. Closure property under multiplication. Here in generalization, A, B belongs to Q. Then A minus B also belongs to Q. Next, two, minus 6 belongs to Q. Then 2 into minus 6 is also belongs to Q. 2 into minus 6 is also belongs to Q. Next, 7, minus 7 comma minus 4 belongs to Q. Then 7 into minus 4 also belongs to Q. This is a closure property under multiplication. Closure property under multiplication. Next to division. Division. So here 1 comma 0 belongs to Q. Then 1 divided by 0 or 1 divided by 0 does not belongs to Q. Does not belongs to Q. So it is not satisfied. So next another example. Closure property under division. 1 comma 0 belongs to Q. Then 1 divided by 0 is not defined. Not defined. So it is not satisfied. Next commutative property. Commutative property under addition. Commutative property under addition. So what is commutative property? Commutative property means suppose minus 3 comma minus 2. Minus 3 comma minus 2 belongs to Q. Then minus 3 plus minus 2 is equals to minus 2 plus minus 3. Minus 2 plus minus 3. So here minus 3 minus 2. Then plus into minus minus. So in bracket means product. Plus into minus is equals to minus 2. Then minus 2. Here also plus into minus is equals to minus 3. Minus 3 minus 2. So the resultant number is minus 5. Minus 2 minus 3. Then also minus 5. So it is satisfied commutative property under addition. It is satisfied under commutative under addition. Another example 6 comma minus 9 belongs to Q. Then 6 plus minus 9 is equals to minus 9 plus 6. So 6 plus into minus minus 9. Here minus 9 plus 6. Minus 9 plus 6. So 6 minus 9 how much? Minus 3. Here also minus 9 plus 6 is also minus 3. So it is also satisfied with the commutative property under addition. So in generalization, general form. Generalization, general form means A comma B belongs to Q. Then A plus B is equals to B plus A. A plus B is equals to B plus A. It is a commutative property under addition. Next, Commutative property under subtraction. Subtraction. For example, 1 comma minus 7 belongs to Q. Then 1 minus of minus 7 is equals to minus 7 minus 1. Here 1 minus into minus plus 7 is equals to minus 7 minus 1. This is 1 plus 7 is equals to 8. That is equals to minus 7 minus 1. So minus 8. It is not satisfied. It is not equal to. Minus 8 is not equals to minus 8. Then it is not satisfied. It is not satisfied the property. Subtraction is not satisfied with the commutative property. Subtraction is not satisfied with the commutative property. Multiplication. Multiplication. So 2 comma 3 belongs to Q. Then 2 into 3 is equals to 3 into 2. 2 3s are 6. Also 3 2s are also 6. Another example, minus 5 comma minus 8 belongs to Q. Then minus 5 into minus 8 is equals to minus 8 into minus 5. So minus into minus plus 5 8 are 40. Minus into minus plus 8 5 are also 40. So this is satisfied. This is satisfied under multiplication. Commutative property under multiplication is satisfied. Under multiplication is satisfied. In general form, A comma B belongs to Q. Then A into B is equal to B into A is also belongs to Q. A into B is equal to B into A belongs to Q. This symbol is belongs to. Next, division. Division. So 5 comma 6 belongs to Q. Then 5 divided by 6 is equals to 6 divided by 5. Is it correct? 5 divided by 6 is equals to 6 divided by 5? No, it is not equal. 5 by 6 is not equal to 6 by 5. It is also not satisfied under commutative property under division. So, not satisfied. Not satisfied. Next, associative property. associative property. Associative property means here three numbers, that is 1, 2, 3 belongs to Q. 1, 2, 3 belongs to Q. Then 1 plus 2 plus 3. 1 plus 2 plus 3 is equals to 1 plus 2 plus 3. 1 plus 2 plus 3 is equals to 1 plus 2 plus 3. Then 1 plus 2 plus 3 how much? 5 is equals to 1 plus 2 how much? 3 plus 3. Here 1 plus 5 is equals to 6. 3 plus 3 is equals to 6. So it is satisfied under addition. Associative property under addition is satisfied. Another example, 4, 5, 6 belongs to Q. Then 4 plus 5 plus 6 is equals to 4 plus 5 plus 6 also belongs to Q. 4, 5, 6 belongs to Q. Then 4 plus 5 plus 6 is equals to 4 plus 5 plus 6 also belongs to Q. In general form, A, B, C belongs to Q. Then A plus B plus C is equals to A plus B plus C. This is a associative property under addition, subtraction, subtraction. Subtraction, for example, same numbers 1, 2, 3 belongs to Q. Then 1 minus 2 minus 3 is equals to 1 minus 2 minus 3. 1 minus 2 minus 3 how much? Minus 1 is equals to 1 minus 2 how much? Minus 1 minus 3. Then 1 minus into minus plus 1 minus 1 minus 3. Then 1 plus 1 2 is equals to minus 1 minus 3 minus 4. So it is not equal. It is not equal. 1 comma 2 comma 3 belongs to Q. Then 1 minus 2 minus 3 is equals to 1 minus 2 minus 3. Now 1 minus of 2 minus 3 how much? Minus 1. 1 minus 2 how much? Minus 1 minus 3. 1 minus into minus plus 1. 1 plus 1 is equals to 2. Minus 1 minus 3 minus 4. So 2 is not equals to minus 4. It is not satisfied. It is not satisfied the associative property under subtraction. Next, multiplication. So multiplication. Example. Three comma 5 comma 6 belongs to Q. Then 3 into 5 into 6 is equal to 3 into 5 into 6. 3 into 5 6 are 30 is equal to 3 5 are 15. 3 into 5 6 are 30 is equal to 3 5 are 15 into 6. 3 into 30 is equal to 90. And then 15 6 are also 90. It is satisfied. It is satisfied. Next example is -1, -3, -8 belongs to Q. Then -1 into -3 into -8, that is equals to -1 into -3 into -8. -1 into -3 into -8, 24. 3 8 are 24. Minus into minus plus is equals to minus into minus plus 3 1 are 3 into minus 8. Here minus, so 1 into 24 is equals to minus 24. Then 3 into minus 8 is equals to minus 24. So it is also satisfied. In generalization, general form, A comma B comma C belongs to Q. Then A into B into C is equals to A into B into C into C. So students, this is our chapter 1 rational number. That is some properties we have to discuss. Write in our notebooks neatly, and homework also 2 times is can be do it. So rational number. Some properties.
Hello? Hello? Nara sir? Hello?